Hey everyone, welcome to Simplifying Rational Functions Part 2, where we talk about multiplying today. So let's go ahead and get started with this. So the ideas are going to be the same as the first video. Number one, you got to think about when you multiply rational expressions or functions, you multiply straight across, and what you do is try to simplify before you do anything. You can simplify vertically and diagonally. Okay, so let's look at part A. So number one, what can't be b? In this case, you don't want b to equal 0. Okay, b can't be 0 because of that right there. So let's try to simplify the top. So we have 7 and 6. So you can't simplify this way, but you can take this b away and one of those and be left with 13b times 7 over 6 times 6, right? So that becomes, okay, there's nothing else you can do there. 13 is prime, 7 is prime. And so we take 13 times 7 and you get 91. So this one becomes 91, okay, divided by 12, or divided by 36, excuse me. I want to be really careful. So we have 91b over 36, okay, and we don't want b to be 0. Okay, so there's our first problem. So there's our simplified. Not much you can simplify there. Let's look at number 2. Now, number 2, you can simplify a few things right off the bat. Number 1, I try to look straight up and down first. So I know that 10 goes into itself once. So we can rewrite this 10 times r over 10, right, times 4. You can do 16 as 4 times 4 times r. And now let's get rid of things that are common. The 10s become 1. This 4 and this 4 become 1. Okay, one of these r's and one of these r's become 1. And so what's left? You have this r times 1 over 4. So it's just r over 4, and r cannot equal 0. Again, same thing as above over here, right? 0. Okay, can't use 0 there, makes that whole thing undefined. So let's look at example number 2. Part A, let's simplify 1 over a plus 8 times the 5a plus 40 over a plus 4. So the first part of this is prime, okay? And if we look at the denominator, the first thing here is a cannot equal negative 8, and a cannot equal negative 4 based on the denominators. So the first one is, the first fraction there is prime. You can't simplify that. So let's go ahead and start working in the second part. Notice 5 goes into itself in 40, so factor out 5. 5 goes into 5a. 8 times 40 divided by 5 is 8. Okay, all over a plus 4. And look what cancels out. Nothing up and down, but diagonally, because of multiplication, this and this become 1. So you're left with 5 over a plus 4. Now again, a cannot equal negative 8, and a cannot equal negative 4. Okay? If you want things to be equivalent, they have to have the same domain. Okay, so let's look at part B now. Part B, it's starting to get a little more challenging. If you look at the denominator, you know v cannot equal negative 5, and v cannot equal 1 right away. All right, so you notice hopefully the v plus 5s are going to go away, but let's start vertically. Let's see if we can factor v squared plus 2v minus 3. Okay, so two numbers that multiply to be negative 3 and add to be positive 2 are 3 and minus 1. So there's that numerator. The v plus 5 stays. And now we're multiplying that to v plus 5. Now look, over 1 minus v. Now that's going to be important. So the v plus, you can't simplify vertically, but diagonally the v plus 5's become 1. You almost want to cancel out the v minus 1 and the 1 minus v. Be very careful. They are not the same. What I have to do is factor this out, or factor this is actually equivalent to taking the opposite, factoring out a -1, and I get v minus 1 if I factor out a negative. So now this v minus 1 could simplify with this one. And when I rewrite my answer, I have v plus 3 over, well, the whole thing is just -1, just -1 over -1, which just becomes, okay, you could just do the opposite of v plus 3. That's one way. You could also put -v minus 3. And don't forget your final answer, v cannot be 5, v cannot be 1. So there's our final answer. That one's a little tricky, but I like that one. All right, so let's look at our third and final example. So we have a pretty big polynomial here. 3p minus 12 over 2p plus 5, the polynomial I mean right here. That's going to be multiplied to 6p squared minus 5p minus 50. Okay, so if I simplify this, I can rewrite this numerator as 3 times the quantity p minus 4. This denominator, 2p plus 5, can't be dealt with. It's prime. 2p plus 5 is prime times. That numerator is tricky, but what goes into both 9 and 30 is 3. So I'm going to take 3 out, and I get p minus 10. Okay, so far nothing cancels out. What I need to find now are two numbers that multiply to be 300 and add to be -5. Okay, so let's take a minute. I want to see if you can factor that, and we'll come back and see what you get. All right, did you get 15 and 20? So if I was going to build this numerator, I'm going to go up here and save myself some space. I need two numbers that multiply to be -300 and add to be minus 5. So that's going to be minus 25, or excuse me, minus 15, or plus 15, and minus 20, because we need minus 5 there. So 20 times 15, that's 300, and we want the minus 20. We're going to divide that by 6 and 6. So when I simplify this, I know that 3 goes into this twice, 3 goes into 15 5 times, 2 goes into this 3 times, 2 goes into this 10 times. So we get here 2p plus 5 times the quantity 3p minus 10, 3p minus 10. Now be very careful. 3p minus 10, look, 3 and then p minus 10, that's not the same. But the 2p and the 5, 2p plus 5, 2p plus 5, this 3 and this 3 are gone, p minus 10. That does not simplify. So we are left with p minus 4, that quantity, times 3p minus 10 over p minus 10. And we would have to know that when we simplify this, p cannot equal 10. And because of this, p cannot equal -5/2. Okay, so that's our final answer. So that is multiplying rational expressions. If you have any questions or comments, go ahead and type them below, and we will see you next time.